All right. So in this problem, we're given a slightly more complicated one. Y equals 1 over x plus 1, and y equals negative 1/3 x plus 1. And we're going to take that revolve it about the x-axis. This is another one we're actually going to do both ways. We're going to do it by washers, although the washer one is going to be a little messy, so we're just going to use our FNIT feature to compute that. So let's first take a look at the graph here. So I graph these two functions using Desmos. And so here we are with our picture. Also using Desmos, I made sure to find my points of intersection for the two curves. 0, 1, and 2 1/3. 2 1/3. Okay, so I want to do this first. First, again, let me indicate my axes here, revolving about the x. And I want to do it with washers. If I'm doing it with washers, remember we always want to measure perpendicular. So we're going to measure our rectangle perpendicular to the axes that we're revolving about. And so you can see that the purple line is always going to be the top equation, and the green line is always going to be the bottom equation. And so then we can see along the x, we would be going between 0 and 2 as we move along the x. All right, and so now we're ready to set that up. We're ready to set that up. So with washers, remember, it is the volume is pi times the integral, in this case from 0 to 2. And then it's going to be my upper function squared, that radius. So that's going to be negative 1/3 x plus 1 squared minus my lower function squared, 1 over x plus 1 squared dx. And so this is one we could do by hand. It's going to be a little messy. It is going to be a little messy. You'll have to use a substitution to do the 1 over x plus 1 squared integral. This one, of course, would have to multiply it out and eventually, get there. But I'm going to, at this point, approximate numerically. And in this case, it actually comes out exactly. But we're going to approximate numerically by using our FNIT. Okay, so I'm just going to go over to my calculator here, and there's my integral. As you can see, negative 1/3 x plus 1 quantity squared. I put the multiplication here because I wasn't sure if my calculator would realize the x should be multiplied by the whole fraction, or if the calculator would accidentally think I put the x in the denominator. So that's why I did that. I wasn't sure with this calculator how it was going to behave. So that's my top function squared minus my bottom function, 1 over x plus 1 squared dx from 0 to 2, and I get the decimal 0.962 and so on. But then I can take that decimal and convert it over to a fraction and get 8/27. So again, I intentionally did it without the pi so I could convert that over. And so I get 8 pi over 27. So again, that was doing the integral with washers. Now, if we're going to do it with shells, then cylindrical shells, then we need to measure parallel to the axis. So measuring parallel, I'd be looking at measuring something like this. Let me draw it. So I'm going left to right. And of course, measuring parallel to the x means I'll be integrating up the y. So I'll be going from 0 to 1 as I move up the y, taking these different heights. And of course, the gap where it's currently at will be in terms of the y variable. So what that means, first of all, if I'm going to be integrating with respect to y, is I need to take those two equations there and I need to convert them over to functions of y. So that's the first thing. And then my integral will be from 0 up to 1. Right, 0 up to 1. And so let's first take my two equations and convert them over to y, as we now do this with shells. So my first equation is y equals 1 over x plus 1. So I'm going to flip-flop the x plus 1 and the y. And that gives me that x as a function of y is 1 over y minus 1. And same thing with the other equation. I need to convert that over to x as a function of y. So we do that. Y equals negative 1/3 x plus 1. So multiply everything by 3. Well, first I guess bring the 1 over, get y minus 1, and then multiply everything by 3. And that'll give me 3y minus 3 equals negative x. And so multiply 3 by negative 3y plus 3 equals x. So now I have my two functions expressed in terms of x as a function of y. And then we just need to go back up to the picture here to fill in the final detail. In every one of these rectangles here that I'm moving, the blue rectangles, the rightmost function is always the line. And then the curve is the leftmost function. So it's going to be right minus left. Right minus left. All right, and then we're ready to go in and set up our shells formula. So for shells, it's 2 pi integral 0 to 1 of y times the difference, that gap. And that gap will be my top function there, negative 3y plus 3 minus my bottom function, which will make that minus 1 over y plus 1 dy. And then we go through and we're not going from 0 to 1. I'm totally missed a very, very important detail, and that is that these things intersect right here at 1/3. So this is actually going to be the integral from 1/3 up to 1, not 0 to 1, because there's no graph here, right? There's no graph here. This is getting into this region that's not between the two. So sorry about that. That's not 0 to 1. That is 1/3 to 1. Okay, and then we clean this integral up and simplify it. Okay, clean this integral up and simplify it. So 2 pi integral 1/3 to 1. We multiply through by y. That'll be negative 3y squared. And then here I have a 3 plus 1 would be 4. So plus 4y. And then y times 1 over y makes that minus 1 dy. And we integrate 2 pi integral of negative y cubed plus 2y squared minus y evaluated at 1/3 and at 1. And again, this is something you can very quickly do on a calculator. And so let me just go ahead and pop out to a calculator to do just that. Okay. So I'm just going to leave the 2 outside. Again, I'm not going to include the pi right now because I'm going to attach that at the end. So it's 2 times. And then when we plug in 1, that's just going to be -1 cubed, be -1, plus 2 times 1 squared would be +2, and -1. So it turns out, of course, that stuff is all just going to be 0. And then we plug in 1/3 minus the negative of 1/3 cubed will be 1/27. 1/3 squared will be 1/9, so that'll be plus 2/9, and then minus 1/3. Okay, and then of course the 2 outside. So that gives me 8/27. That gives me 8/27 as a fraction. And of course we attach our pi. And it's the same answer we got the other way. Numerically, 8 pi over 27. 8 pi over 27. Okay, so just to see there that that works, and also kind of confirming our numerical method. Again, this is one you may want to challenge yourself and work that out by hand. We can definitely do it. I just wanted to save on the work here, and also show you this numerical idea again. Okay, so good luck with that.